Assalamu alaikum. In this video, we will go over the snake ladder game explanation and operation. At the end of the video, we showcase the gameplay and show how it is played. Here board module, individual LED are used with distinct roles. The red LED indicates the player 1 position, the blue LED shows player 2 position, the green LEDs marks both bottom and top of a ladder, and the yellow LED shows snake's head and tail position. The board has total 16 blocks. Each block contains 4 LED that represents full game information. All LEDs shares a common power supply. All LEDs anode shares a common power supply as since the LED are designed as active law components. On a 4-bit binary number is applied to the LED board, the corresponding LED matching is equivalent, and then LED lights up. Additionally, the decision to use a common anode for power supply helps reduces the number of ICs needed. This is because a widely available active load decoder outputs 0 instead of 1. This is an active load decoder which gives output 0 instead of 1. Because of this, we have to use extra NOT gate for all LEDs. This requires extra number of ICs, which is not an optimized version for our PCB. So we have to use this anode as common power supply to overcome this problem. Finally, all LED connections are combined to form the complete configuration. Thank you.
Assalamu alaikum. Today we are going to examine the dice model of our snake and ladder game. This model is responsible for generating the dice roll, and we'll explore how it works. So, at first, here we have used 555 IC timer. The IC timer is set on a stable mode. This mode generates a continuous series of pulses, making it an oscillator. Here, an external capacitor charges and discharges through resistors, determining the frequency of and duty cycle of the output pulses. Here the two resistors are used to calculate the frequency of this IC timer. Here we can use a simple formula which can determine the frequency of this IC 555 IC timer. Here we have used a large hollow capacitor which can determine the frequency, and it can make it lower than the previous one. Using this capacitor, we can slow down the dice frequency and observe their many operations. Here we have used 2D flip-flops to build the circuit, and this circuit can determine the output of 1, 2, 3. And in the player selector module, we have used a T flip-flop, and this flip-flop can trigger from position 0 to 1, 1 to 0. Here 0 means player 1 and 1 means player 2. And a NAND gate is used to the clock and the switch of SW TPST mount switch, and these two output will determine if the dice is pressed or not, and this output will show here in this tab. Let's run the module. At first we will try the original one. So both modules will be triggered at the same time through this SW TPST mount switch, and this is the advantage of switching players and the dice pressing at the same time. Now we'll try the slow one. Here the output will come with low frequency. So the demonstration of player selector and dice model ends here.
This is the snake ladder logic module subcircuit. In this module, there we use ladder, mux, comparator, and demux. This is the complete 4 input 8 output demux. How did this demux works? This is the selection button between player 1 and player 2. First of all, we come to this adder. This adder add player position and dice value to this adder, and output of this adder are sum of player position and dice position. This output will be this output gone to this marks, and this marks operates on selection button come. This selection button is the input output of this ladder carry. Why this marks is used? Because the when player position and dice value sum value is above 15, then it gives some carry. This carry, that means this carry will works as a selection button. On this it gives some carry, then it select B. What is the B? B is the current player position. Then it passes the current player position when the player position and dice value is above 15. So this marks is for that purpose. And then the ladder comparator compare between ladder bottom position and player position. When these positions are matched, then A is equal to B gives output 1. This output 1 enables this AND gate. This AND gate passes ladder length and added to the current player position. This ladder output also go to this multiplexer. Why this multiplexer? When the length is and current position added, and when it goes to above 15, then it cancel out the ladder length and remain the player position as initial one. So this marks is used for that purpose. After this marks output, it will go to snake comparator and this snake subcircuit. Why this? Because we prioritize first ladder position, then snake will come. When in one position, snake and ladder both will come, then we prioritize ladder position. So this, because of this, first of all, ladder function works, then it goes to output. The snake will not work as we prioritize this ladder position. For snake position, snake comparator compares between snake head and player current position. If this matched, then this AND gate will enabled and passes the snake length. This snake length subtracted to the current player position, and because of this output of the snake subtractor will go to these marks. Why these marks? It also when this subtracted value is less than 0 or below 0, then it cancel out the ladder length and remain the player in initial player position as intact. Then this multiplexer outputs go to this demultiplexer. However, this is the selection button between player 1 and player 2. When 0 is come, then player 1 activated. When 1 is come, then player 2 activate. This is the working procedure. Now I run this circuit and show the above circuit. This subcircuit is a special feature of a dice value 1. At the beginning of the game, player position must be 0. So in this subcircuit, we use one comparator, 2 marks, and other logic gates. So this comparator compares player 1, player position. When player position is 0, here and B all are grounded, shorted and connected to ground. So this comparator compares whether this player position is 0 or not. When player position is 0, then A is equal to B passes 1, and A is greater than B passes 0. This A is greater than B connection shorted to these marks. When player position is 0, then it activates this AND gate. And as well as when dice value is 1, this is for dice value 1 circuit, 1 logic. When dice value is 1, it passes 1, and this AND gate enable and passes 1. For fast marks, selection button for 1 is for player position B. B is shorted to the dice value. So marks output will be directed to this second marks. So for second marks, selection button is directly shorted to this comparator A is greater than B output side. On at the time remaining, player position will not be as 0. They will have some value. So A is greater than B always comes 1. So this is for 1. When A is greater than B is equal to 1, then B is passes to this marks. What is B value? B is the dice value. So this circuit will work when player position is at 0 and dice position is at 1. I hope this sub-circuit. So now this IC is adder. So first of all, we keep player position 2 and dice value is 1. So 2 and 1 is output gonna be 3. So this is the selection button of these remarks. Each selection between player 1 and player 2. When 0 comes, then player 1 activated, and when 1 comes, then player 2 activated. So this adder also works properly. After this adder output goes to this marks. Why will you use this marks? Because when player position is like 14 and dice value is 3. 14 is and 3 is equal to what? 17. So 17 is above 15. Above 15. So it passes some carry. This carry works as a selection button of these marks. So it passes B value. What is the B value? B value is the initial player position. So it passes 14. Here is the output of this 14. See, 17 will not passes. Why? Because of these marks. So these marks will also works perfectly. After then, we use this ladder bottom position. We keep this player position to 2 and 3. Dice value is 3. Then 2 and 3 is equal to 5. This is 5. And we keep this ladder bottom position also 5. Then this ladder land will also keep 5. Then 5 plus 5 is equal to 10. See, this output is equal to 10. So ladder also works perfectly. There have some invalid case also. Ladder position is when above 15, then it will not passes. Like on 5 and like 10. This is 14. 5 plus 14. It will remain same. So this carrier will passes 1. Because of this 1, it will remain the same as player position. So this is the invalid case. And next we got to snake comparator. First we priority this ladder, then snake. When two ladder bottom and snake head are gonna be same position, then the priority will ladder. When ladder is something, then it works properly, but not for snake, because as we priority this ladder, then after we works how this snake comparator works. Like we given this as 8, 10. 10 plus 3 is equal to 13. See, this is 13, and we place snake head to 13. Here is 13, and snake length to 13. Then it will remain 0. See, it will remain 0 value. Then it will remain 0. When snake length is like 3, 3 minus 13 minus 3, it will gonna 10. See, snake position will also works perfectly. These are the complete overview of snake ladder logic module. Thank you. This module, it contains memory module, winning module, and reset module. In memory module, we use 1 DMAX and 3 marks. And for your store data, we use 2 parallel in, parallel out data register. And now, when player 1 is playing, then this register will remain on and this will become off. And when player 2 is playing, then this register is off and this will turn on. For each player, there will be 1 register on. And this multiplexer have their special uses. This multiplexer is to show the real-time data for current player position. When this multiplexer selection button is sorted to these demarks. When player 1 is playing, and it stores it sorted to this multiplexer A. A value and B value is sorted to this data register output. Because of this triggering, when player 1 is playing, it will show this player 1 position value, and next trigger it will also store this data this to this. This data will also show as in this value. So then if we run this circuit, we can see that for player 1 position, player 1 is currently at 3 position and player 2 is currently at 2 position. We have to store this data and to this data register. So 0 is for player 1 and 1 is for player 2. When 1 comes, then player 2 playing, and when 0 comes, then player 1 playing. This is the player selector output and this is the dice value output. When player selector is 0, then player 1 is playing. So we have to store this data to this dtype register. So we have to trigger and like push the dice value. When we push the dice value 0 to 1, then it trigger and save the current data to this dtype register. For player 2, we have to change this player selector 0 to 1. When 0 to 1 goes, then we have to push the dice value again. When we push the dice value again, then it will also save this data to this dtype register and show the corresponding output value and lights up the LED. This is for the player selection between player 1 and player 2. Here, when player 1 or 2 comes 15, then buzzer will turn on. Like I said, when player 1 is 15, then buzzer will on. When player 2 is 15, then buzzer will also on. This is the complete demonstration of memory module and reset module. For reset module, here we have to push the reset button, then automatically memory data will be reset. When we push it, then memory data will automatically reset. This is the all demonstration I have shown in this sub-circuit. Thank you. This is the whole integration of the circuit. Here this is the memory module, this is player decoder, this is warning module, this is the reset module, snake, ladder, logic module, and this is snake position decoder, and this is ladder position decoder. These whole circuit are dice module and player selector module. Now we demonstrate the gameplay. When we run the circuit, or initially player position is 0 and we have not yet given the value of ladder length and head or snake head or tail. So this position remains 0. As when we give the ladder snake head to 13 value and snake tail, snake length rule is 10, 8 plus 2, 10. Then 13 LED will blink up, and 13 minus 10 is equal to 3. Then 3 LED will also blink up. Here 13 LED is turned on and 3 LED is also turned on. For ladder bottom, for we keep it 4, and for length that is going to be 8. So 4 plus 8 is equal to 12. So 12 LED will, for 12 LED is turned on, and 4 LED is also turned on. Now we roll the dice. It comes 1. So player 2 is playing. So player 2 current position is 1. Next turn is for player 1. Player 1 is dice value comes 2, but output remains 0. Why? As we previously discussed this. When dice value come 1, then it will start the game for individual player. But in this time, this player 1 position, the dice value comes 2. So output will remain 0. So next rolling player 2 is playing. When player 2 is playing, then previously player 2 is 1. 1 plus 3 is equal to 4. But at 4 position, ladder length, ladder bottom here. Ladder bottom is here, so it will directed to the 12 position. So player 2 current position is 12. And now player 1. Now player 1 comes 1. So for player 1, LED is turned on. Now it will automatically directed to player 2. Previously player 2 is 12. 12 plus 2 is equal to 14. So player 2 current position is 14. So 14 LED will blink, is blinking. Now this is for player 1. Previously player 1 is 1. Now this is 2. 1 plus 2 is equal to 3. Done. So player position, so player 3 LED is turned on for player 1. For player 2. For player 2 it comes 2, but previously it comes 14. 14 plus 2 is equal to 16. So this is an invalid case. So it gives the previous value. So player 2 remain at same 14 position. Now for player 1 turns 1. Previously at 3. 3 plus 1 is equal to 4. As we see that in 4 there is a ladder bottom, so it automatically directed to 12. So 12 LED of player 1 is turned on. Then player 2, it also come to. So this is also invalid case. So it will remain same. It will remain same. And it is for player 1. Player 1 is 1 win the game. So we have to reset the circuit. So when push the circuit, then it automatically reset the player 1 position to 1 and 2 position to 0. Here this reset function works. This is the complete gameplay demonstration I have shown this video. Thank you. In the previous section, Python showed a function of ladder, but the snake functionality could not be shown. But in this section, we will see the snake function only. To see the snake function, we have to control the dice value. For controlling dice value, we must keep frequency around 1 to 10 Hz. So now, run the circuit and keep the snake at position as previous one and length is 10. So 13 LED is turned on, 13 is turned on and 3 is turned on. Now roll the dice. 1 for 1, player 2. 2 that is blue. Blue LED is turned on. For player 1, that red LED also turn on. As well, controlling the dice. 3. Previously blue one is 1. 1 plus 3 is equal to 4. For red one, that is also 3. So both are in 4 position. Next 1. So in previously blue is at 4 position and 4 plus 1 is equal to 5. Now for red one, previously 4 plus 3 is equal to 7 position. So 7 LED for player 1 is turned on. Now then again for blue 3. Previously 5 plus now 3. So 8 LED will turn on for player 2. For player 1, previously 7 plus 3 is equal to 10. For player 1, 10 LED will light up. Now for player 2, previously 8 plus 3 is equal to 11. So 11 light is turned on. For red one, at 13th position, snake head LED is turned on. For player 1, we have to keep the dice value at 3. So previously player 1 is at 10th position, so now we have to 3. So as 10 plus 3 is equal to 13. But in 13th position, snake head gonna eat player 1 and directed to 3 position. So snake function is working perfectly.